Hello everyone, welcome back to Exam Prep Solutions. In today's video, we're going to be tackling finding the moment in a simply supported beam. This is a great static structural engineering problem. So break out your calculator, your FE manual, and we're going to dive right into this problem here. Okay, let's read out the question. A simply supported beam with a length of 10 feet carries a uniform distributed load, that's important, make sure to make note of that, of 200 pounds per foot over the entire span. What is the maximum bending moment? So we're going to approach this one step at a time. If you need a 5-step plan for approaching every single problem on the FE exam, I have a manual down below, the 5 steps to solving any FE exam problem. That's the template that we're going to use for these practice problems. You can find that in the description down below. Go ahead and try to solve this one before I launch into the solution. The first step is identifying what we need. We need the maximum Mmax. A maximum bending moment is what we're trying to solve for. We're given the length and the uniform distributed load. Now, you may be tempted to do some basic statics, draw out the diagram and try to find the reactions and then try and find the moment. A question like this is not trying to have you do that. What they want you to do is find the diagram in the FE reference manual that discusses finding a maximum bending moment given a distributed load. So I've got the FE reference manual on the side here. Now, you could search for maximum bending moment. That's going to give you generic equations, and I don't think is the best way to search for what we're trying to find. What I want to search for is simply supported beams, because when you search for simply supported beams, it brings up all these tables here: beam, slope, deflection, elastic curve, and maximum moment. This is super crucial on the FE exam for very quick reference. So note, when they ask you a question like this, they want you to search for it on the tables. So we want to find the maximum bending moment of a simply supported beam. Well, we've got one here. Why don't we go with PL over 4? Well, it's not a uniform distributed load. This is a singular load. The question is asking about a uniform distributed load. So let's scroll down. This is a uniform distributed load of a simply supported beam across the entire span, which is what it says here. And the equation we get is WL squared over 8. Is actually what we're going to be using on this problem. And that's really nice. When we think about W is the uniform distributed load, which is 200 pounds over foot. 200. Length L, 10 feet. That's going to be squared. I think we can all do that one in our head. That's going to be 100. And then it's all going to be divided by 8. Let's do a quick equals. 20,000 divided by 8. That gives us 2,500 pound per foot, or pound feet, I should say, not pound per foot, but pound feet. Let's think about the units here real quick to make sure that we solve this problem correctly. W was pound over foot, right? L was feet, but it was squared, so it was feet squared. We multiplied those together. What exactly do we get? We get pound times feet. So we know that the units came out to the correct answer. So we're going to go with answer A on this problem. So quick tips: understand what they're asking and what they want. Lookup tables are very, very useful on the FE exam, as it quickly gave us the solution. Understand what terms to search for on the FE exam. Simply is going to give you a much better, or simply supported beam, something like that is going to give you a much better result than just looking up maximum bending moment. For example, if I just look up maximum bending moment, it's going to give you, look, or if you look up maximum, look at all the different results that pop up, not things that are useful. So to make sure to reference the correct thing. So that's how to solve that problem. If you need the free guide, you can find that in the description down below. If you're looking for direct help or a plan to help you pass the FE exam, you can contact me down below as well. If you have any questions, please leave a comment. And anyways, I'll see you guys in the next video.